explanation of surfaces of revolution. So here we have an ellipse, and if we do a rotation around x, we get something that looks like that. And let's go ahead and trace that out. Now, let's try that. There it is. So you can see how we get this surface to be created, just to give you some idea of kind of what it looks like. So skipping ahead, we get to this. If we clear everything off, go a different direction, and look at this one. And you can see some of it get painted out this way now. It depends on which way you go. We'll only go in one direction at a time. So skipping ahead here, it's getting spun out. Okay, I think you get the idea. Alright, so we're up on the surface area. This is ds, a small bit of surface, and you're rotating this curve about the x-axis. And so this little band is 2 pi r ds, where this is your radius, the distance from the axis of rotation up to wherever your curve is. So this would be the area. You've got to add up all these little strips, and so now this ds is actually your arc length, right? We just did arc length, that's ds is an arc length, so it's 2 pi times y, where this is your y value, if you're doing it above the x-axis, and here's your arc length, which was a ds is now your arc length. That's why this comes directly from the arc length. So it's 2 pi times your radius times your height, but your height is actually your arc length. Okay, rotating this about the x-axis. The y-axis, of course, we'll get a cone. So if we solve it for x, and we've got dx dy, so then we have y is going from 0 to 4. You have 2 pi times the radius. Radius is x times your height, which is basically your arc length. So here's your arc length formula, and then a lot of algebra later. A lot of which we'll do in the calculator because we're more concerned with setting up the integral. We get all the way down to here, 15 pi, which is actually correct if you judge this on pi times radius times slant height to give you your value. But take this about the x-axis, we get what's called a paraboloid. So 2 pi, x is going from 0 to 9, your height is a y value, and here's your arc length. And so this is using the calculator, about 117. And then rotating this about the x-axis, of course, we should get the surface area of a sphere, and 12.56, which is 4 pi. Okay, looking at some examples over here. We'll take this curve 1 over x, and from 1 to 3, and wrap it around y equals negative 2. Okay, so here's y prime. So our surface area S is equal to 2 pi. Here's our integral. Our integral from 1 to 3, and then y plus 2 because our radius is y plus another 2, and our height is our arc length, which is the square root of 1 plus y prime squared, and then going ahead and trying to solve this. We get all the way over to here, which is about 30.4.578. You see here I have it on the calculator, how you do the syntax there. This is using a free program called WinPlot, where you take y equals 1 over x from 1 to 3, and you do it in 2 pi, and you can see this is what it looks like, but just rotated a little bit sideways. This is sine x from 0 to pi on the x-axis. So we've got 2 pi, from 0 to pi, our radius is y, our arc length is rad 1 plus cosine squared x because the derivative is cosine x. And so we come out with 2 pi 0 to pi sine x rad 1 plus cosine squared x. Here's how you do it in the calculator, and we end up with about 14.24.